Okay, in question 10, we want to sketch the graph of the function by plotting points. So we're going to plot them by points, so we're going to be able to create a table, and then we're going to graph just by using the translation. So in this scenario here, we have our function g of x, which is equal to 1 plus the log of x. We have our values for x, and we're going to plug that into the function. So the first value of x is 1 over 10 to the third power. So therefore our function would look like y, which is equal to the log of 1 over 10 to the third power. Now this is a common logarithm because it's an log and it doesn't have a base listed there, so we have to assume it's 10. So rewriting this as exponential form, y is the exponent on base 10 to get 1 over 10 to the third power. And therefore we get 10 to the y is equal to 10 to the negative third. Now we get that negative 3. But then keep in mind here that we have this 1 we have to add to each one of those. So if you add 1, then you get negative 2. So therefore the output here is negative 2. Next, we have the input of 1 over 10 to the second power. So we plug that into the function, and we're going to change that to an exponential function. So y is the exponent on base 10 to get 1 over 10 squared, and 10 to the y power is then going to equal 10 to the negative 2. So we get negative 2 as our value, but then again, we're going to have to add that 1, which gives us negative 1. Okay, next, we're going to input 1 over 10. So we have y, which is equal to the log of 1 over 10. Rewriting that in exponential form is 10 to the y power, which is equal to 1 over 10. And then writing them with the same bases, we get 10 to the y, which is equal to 10 to the negative 1. So we get negative 1. And then again, add that 1 to give us 0. And therefore, there's our ordered pair. Next, we have an input of 1. So we have y is equal to the log of 1, which is the same thing as y 10 to the y power, which is equal to 1. And another way of writing 1 with a base of 10 would be 10 to the 0 power. And so therefore, that value is 0. And if we add 1, then we get 1 for our output. Okay, next, we have y, which is equal to the the log of 10. So we have 10 to the y, which is equal to 10, which is the same thing as 10 to the y, which is equal to 10 to the power of 1. So we get 1 as the exponent, and then again, we're going to add 1 to get our value of 2. Okay, and the last one here, we're plugging in 10 squared. So we have y, which is equal to the log of 10 squared. So that means that we have 10y, which is equal to 10 squared. So the exponent is 2, and then adding 1 to that equals 3. So therefore, when the input is 10 squared, the output is 3. Okay, now, if we want to graph this using graph translations, we're going to identify the vertical shift. Okay, so the vertical shift is 1. So that means since d is greater than 1, we're going to be shifting it up d units. So therefore, there is our first part. Then we're going to draw the vertical asymptote at x equals 0. So there's our vertical asymptote, x equals 0. Okay, and then what we've done is we've graphed the parent function on this graph, and the parent function would be g of x, which is equal to the log of x. So what I've done is I found 3 points on this graph. One of them is 1, 0, the other one is 10, 1, and the other one is 100, 1. And so since we are shifting the graph up 1, that means our x value is going to stay the same, but the y values of these points are going to change by adding 1 to them. So for the first order pair, if you take 0, we're going to add 1. That's going to give us 1, 1. So there is our graph there. And then again, we're going to add 1 to the order pair of 10, 1, which ends up giving us 10, 2. So there is our other order pair. And then our last order pair is 100. And then the x value is 2, so we're going to add 1 to that, and that gives us 103. So therefore we have 103, and there's our point that we plotted. And so then what we're going to do is we plot those points and then connect it with a smooth curve. So now we have our translation graph. And so the domain of this graph is going to be from 0 to infinity. The range goes from negative infinity to positive infinity. And then the vertical asymptote is going to be x equals 0.